Good morning, welcome to EduSet Network. Friend, today we have concluding lecture on 5 days series of lecture on computer science. We try to understand the different aspects of wireless network. We have started from basics, fundamentals, and then we talked about the various network of wireless network like LAN, MAN, and WAN. And yesterday we particularly talked about the cellular network, and we'll move further. We'll talk about in detail today lectures. And for discussion on this very topic, we have in studio the same resource person, Dr.D. He teaches computer science in Jawaharlal Nehru University. He is associate professor there. His area of interest is the wireless network. So I think his knowledge and experience will help us to understand this topic. So on behalf, I welcome him for EduSet lecture. Welcome, sir.
Thank you very much, Amrenji, and good morning, everybody. So this is the final lecture of the 5-day series or 5-lecture series, and we started with the fundamentals of wireless network, and then various kinds of network, LAN, WAN, WAN, and then especially we focused on 802.11, and yesterday our journey was towards cellular networks, and I'll continue with where I left, and then towards the specific kind of cellular network which GSM. This is what the today's focus will be on. But if you look at the diagram which has been showing for last 4-5 days, that is basically for the categorization of wireless network, and that very well tells you how much to cover in this wireless networks. Even satellite systems itself is a big topic of discussion, and then paging system and so on and so forth, Bluetooth, and there are various versions of cellular network as well as various kinds of local area network, and we left Bluetooth as well, which you use in your mobile phones. And let me begin with, this is what I talked yesterday, and now let me set this first, that how 2G started with, because this is very important. And the first generation, as I said, was analog communication, and that was a very limited choice for voice communication. Now with 2G, that is where the GSM begins with. Global system for mobile communication begins with 2G, because everything became digital. So 2G was developed for voice communication, and up to 2G there is no data communication. So voice communication with little higher speed, and that is where you introduced GSM, global system for mobile communication, and the rate for 2G was 3 kbps to 9.6 kbps, and this increased data rate of 9.6 kbps also gave a little what you call insight towards moving towards internet applications, and that is what led to 2.5G. And we have different systems of 2.5G, and where GSM also comes in, and for high speed data transmission, and where you achieved a speed of 57.6 kilobits per second, and whereas GSM is still used in about 160 countries, and which includes Europe and India. And this IS-136 was a parallel system which is called interim system 136, was developed by US, and that is what you call CDMA based, and it uses 171.2 kilobits of data rate. Now another technology came, EDGE, for 2.5 GSM, and then US continued the IS-136, and then the data rate increased up to 384 kbps, and that also led to evolution of further development came with the evolution of CDMA, core division multiplexer systems. And if you look at, and then interim system also evolved from 136 to we reached towards IS-95B, because earlier there was a 95 IS-95 interim system, and that was giving with CDMA 64 kbps speed. Now that is how we move towards 3G systems, because there was a question yesterday how the technology developed and advanced, and that is what I thought it may be important. Now the voice and data transmission simultaneously to be used was one of the primary aim of 3G systems, and then it targeted towards the megabit speed, which may be useful for internet access and interactive web sessions. That was the primary aim, to have 3G systems, and then voice activated calls, and important was the multimedia content, and like live music, and to certain extent you can have movies to be played on the 3G. That was how the evolution goes, and GSM begins with 2G and then it moves towards 3G now. And if you look at this entire evolution and how CDMA was developed, initially in 2000 it came with the CDMA 2000, and it has various versions and provides speed from 307 kilobits per second to 2.4, and then 1.44 kbps was a system earlier, but 2.4 Mbps was the target. And parallelly, if you look at GSM and IS-136, and that evolved towards WCDMA, that is wideband CDMA, also called UMTS, that is Universal Mobile Telecom System, and which targeted at 2.048 Mbps data rate. And probably future system what we have been talking will lead towards 8 Mbps, or it may be developed soon. 10 Mbps, we said 4G has a target of 10 Mbps, and then of course 5G towards 100 GPUs. And having said this, let us move towards global system for mobile communication. That is an overview here. Now, what we talked when we have been talking about cellular networks, and then we said there are MSCs and there are base stations, and then there are mobile stations. Now, look at this diagram. We have a base station subsystem, the dotted line rectangle on the left side, and then if you look at right side, it is a network subsystem which includes your mobile switching center, MSC, and then this base station subsystem consists of BSC and BTS, and BTS stands for base transceivers and BSC for base station centers. So, now that means you may have a BSC, and BSC connects several BTS, and these mobile stations communicate with BTS. Now, this MSC has certain databases, where I say HLR, VLR, EIR, AUC. These are databases, they will be stored, and they are very, very important as far as the communication is concerned. Now, there may be a question very well will arise, which from the yesterday we said there is a base station, and then we talked about MSC. Now, here I am saying base station and BSC as well. Now, this BTS is responsible for assigning channels and identification of users. That means, whereas certain mobile stations are within the range of this or not, but whereas BSCs may be taking care of the handovers between BTS. That means, several BTS are connected to a BSC. If a mobile moves from one BTS to another BTS, that is what I said, one tower to another tower. So, the handover takes place. That is what I talked about, certain definitions yesterday, what is handoff mean, and now. So, when it changes from one BTS to another BTS, then how it manages, that is where the BSC comes into picture. It try to manage the handovers. Now, before I move further, the handovers are very important. How to deal with the handovers? One of the techniques of handover is called guard band based technique. The moment I say guard band, now assume that you have 100 channels with each base station. That means, at a given point of time, only 100 users or mobile stations can communicate. Now, if the 101 comes, then what happens? 1, and that too is 101 may be a new user who wants to make a call, or this 101 may be a user or a mobile station which comes because of the handover from another BTS or another base station. So, now the two kind of users which try to connect to a base station, one is a new user who wants to make a call, another is a user who are already made a call and the ongoing call has to be hand over to this base station. So, there are two kind of users. Now, the first is, if all the channels of a base station are busy engaged, that means they are assigned and allotted to the maximum number of users which it can support, then it cannot take a next user. So, therefore, your call is blocked and you will get a message, now all the routes in this line are busy, please call after some time. That is what that means, your call is not allowed because no channel is free. So, you get this message, and this phenomenon or this concept when a user wants to make a call and his call is not allowed is called call blocking, and that is one of the key parameters of a GSM or a cellular network designing system, because what is the rate of call block, and no system and no user will like that his calls, or when he wants to make a call it is being blocked time and again, it may happen rarely. So, therefore, the call blocking rate is very important. That means, at what percentage of calls, total calls made during a period, if I put it that way, and how many calls were not allowed to go ahead because of the inability of channels, Now, that is what we call blocking rate, and that is when the system are being designed, and that is taken into care that the call blocking rate should be low. And second question I said is, second kind of users which are coming to a BTS is because of the handover from some other adjacent BTS. Now, that is very serious now. The serious is because it is coming because an ongoing call is there and it must be continued. Now, the moment the call is handed over to another BTS, now that BTS or that base station may not have a free channel, all channels are busy. Now, what to do? The only way out is that call cannot be carried forward, the call will be dropped, and that notion, when the call is terminated because of inavailability of a channel in the base station and handover cannot take place, therefore, the call has to be terminated, and this concept is called a call drop. So, two parameters, call block and call drop, or call blocking or call dropping, and call dropping is the most crucial parameter of a cellular network or a GSM network design system, because none of the user will appreciate that his ongoing call is being dropped in the middle, and therefore, the designer must look at what is the call drop rate or probability which is accepted. So, this call drop rate should be as low as possible. It should be very rare that an ongoing call is dropped. That means, one has to ensure that at any point of time when a call is handed over, that you have to ensure, or a system has to ensure, a channel is all the time available. Now, how to ensure that availability of a channel? That is where the crucial point comes. That is why one of the notion is called reserved channels or guard band. That means, certain channels should be always reserved for call handovers. That means, these channels will never be allotted to any new caller. That means, if somebody wants to make a new call, he will not be allotted a channel from the guard channels or from the reserve channels, because they are only reserved for handovers. So, only when a call is handed over to the base station, then only it will use a guard band. Now, there is again a problem. Now, how many guard bands or reserve channels will be available? You cannot have infinite number. Again, if there are n guard bands, then if n plus 1th user comes, then what? And therefore, the two notions comes. One is called dynamic channel allocation. That means, a channel may also be allotted based on what you call is availability of a channel, probably with another base station. It is not that if it may happen that one base station may have all channels full, but other may have some channels free, because it depends on how many number of users are connected to a base station at a given point of time. So, the load on a base station, on all the base station, may not be equally divided all the time, because it depends on the location, the population and the traffic at a given point of time in around a base station. So, that will be variable. Some base station may have more traffic, some may have lesser traffic. So, therefore, the channels can be dynamically allocated by the BSC or MSC depending on what you call the availability of a traffic. The base station where more traffic is there, so it can be allotted more channels, and the base station which has lower number of traffic or less number of traffic, it can be allotted less number of channels. So, rather than assigning channels a priori or beforehand, fixing with the base station, let it remain with the BSC or MSC, and whenever a mobile station makes a request to a base station, then this BSC or either MSC must allocate the channel. So, that means all channels are centrally there, and depending on the request from a base station, and the channels are being allotted. So, therefore, you are taking care of more users, and there will not be reducing the call drop rate. And keep one thing in mind, that always any operator will allot or assign more users than the number of channels it has got. The reason is that at any point of time, that all the users may not be communicating. So, therefore, and one will not like to underutilize the channels, but it depends on the traffic volume also. Even if you have n number of channels, if the users are more than n, then most of the time, and then you have to ensure that n what is there, that n number of users are communicating at any given point of time. It may happen at certain peak times like New Year's on 31st December, you will find that most of the time you do not find a channel, your call is blocked at 12 o'clock in the night, and when you try to send happy New Year wishes, you will find that you are not finding channel, because the traffic volume increases beyond the capacity of a system. But rest of the day you do not find this, because at a given point of time all subscribers are not engaged in communication. So, that always has it is the number of persons or number of users communicating may not be saturated, may not be at the peak. So, that is how the system works. Now, with the MSC, if you look at this diagram, what we have is we have a VLR which you call, and we have an HLR which is called home location register, it's called HLR, and then we have VLR which is called visiting location register, and third is EIR, that is equipment identification register, and then we have AUC, that is called authentication. So, we have four kind of databases: HLR, VLR, EIR and authentication register. Now, what does it do? This HLR, that is called home location register, if I have subscribed a service from MTNL Delhi, the HLR in MSC of MTNL Delhi will store all my information. That will include my address, my identification of my equipment, mobile handset, plus information about my SIM card. All this information is registered with the MTNL Delhi, and that too it is stored in HLR, home location register, because this message switching center is my home location where I have subscribed a service from. Now, those who are from Bangalore, they have subscribed the service in Bangalore, their home location register will be in MSC of the Bangalore, MTNL or BSNL, and this all information will be stored in HLR. That means the information, the permanent information of a subscriber will be stored in home location register of an MSC from where the subscriber has bought the services or had the registration. So, I have my registration in Delhi. So, all information in Delhi now. So, when I have an active call, this all information it will try to see from the HLR. But at the same time, it may happen that I may move to Bangalore, assume that case, and my home location registered in Delhi, and that means my all information about myself is in Delhi HLR. So, therefore, what about my current location information? Now, my visiting location is in Bangalore. So, that means, and you take in that somebody who has registered in Bangalore has come to Delhi and he wants to make a call. That means, he is a visitor in Delhi because his home location is Bangalore and he has come to Delhi. So, this VLR contains information about those users who are not from registered in this network, but they have come from outside. So, they are visitors here, and this visitors information is contained in this VLR register, visiting location register. That may include the SIM information, current SIM information, and current what you call equipment identification, so on and so forth. But and then current SIM information and the now you have EIR that contains the information about invalid equipment registration. That means as well as the valid. That means how do you identify that this mobile is not a registered one? The moment you say no, this equipment is lost and it should be unregistered. Therefore, this EIR equipment identification register contains information of all equipments which are registered here, plus which have been blocked, which are not in use and are declared invalid. And if you hear a news few times back that some of the Chinese phones starting with some numbers, identification numbers were blocked, they are not allowed. So, therefore, this EIR will contain information about all such equipments. That means, the equipment which are starting with this identification number will be declared as invalid and will not be allowed to use this communication system. And therefore, what you find is this equipment identification register contains all this information. And the fourth one is authentication center, AUC. So, this contains and performs the task of authentication of a subscriber, of a user. So, that means the moment I make a call, how do I be identified as a valid user? So, therefore, this authentication center will look in the home location register and so on and so forth, and then authenticate that whether I am a valid user of this system or not, one. And second is, this also will take care of certain security measures, that the information, my privacy is not what you call is only I can change my information and registration information, and that is what I should be an valid user, and whether I am authorized user or not, that authentication as well as security measures has to be performed and checked, and that is what the authentication register does, and the center does the task of this. So, we have four kind of registers or databases which performs authentication of a user, contains information about a user, contains information of invalid and valid equipments, and so on and so forth. So, the MSC has a very big role to play as far as the system is concerned, and in addition to that, it also provides you to be connected with the remaining PSTN, or it may be also to other operator. Now, there is a question. This MSC is also will be performing the task of your billing. So, when you make a call, since it is your home location register is here in a GSM system, and this MSC will pick up all this information, that how many time, what is your dwell time, or how many time you make a call and what was the call duration, all information is maintained in this, and based on that your billing is done. Now, so MSC is the most important component of this system, and if you remember initially there are charges for call receiving, now which has been taken off. Now, you do not need to pay for receiving, and why it happened so was, now each operator has its own MSC, like Airtel has its own MSC in Delhi. If I put the case in Delhi only, GSM based service, all are GSM based service. Say Airtel has its own switching center MSC, BSNL or MTNL has its own, Tata may have its own. Now, when one is making a call from MTNL to Airtel, so that means the call from MSC of MTNL is being transferred to the MSC of Airtel. Now, Airtel further will transmit it to the right mobile station through base stations of Airtel. Now, while you are making a call from MTNL and the recipient is in Airtel, and to receive this service, the all mobile services of Airtel is also being used, as well as the services of MTNL are also being used. So, if only you make a payment for the sender makes a payment, then only payment is being made to MTNL, because he is a MTNL user and making a call from MTNL network. But the recipient is on Airtel, and that also is using the services of resources of Airtel, and which is not being paid for receiving. So, initially to reduce the cost and to make profit out of it, that means their network resources are also being used. So, they should also be paid when the receiver also should pay. So, that is why initially receiver was also paying, because it is using the services of a network. Now, gradually in the larger benefit of the operators decided themselves that even if our services are being used, we will have an agreement that we will not charge each other. Therefore, this agreement was understanding between the operators, and they said no, let us use it free and we will not do, because that will also increase the business. So, from business perspective, they agreed not to charge for receiving. Otherwise, even today on receiving side, the network resources are still being used and they are being managed, because if this provides connectivity between both, so one is being paid. Sometimes MTNL user may be making call to Airtel, sometimes Airtel user may be making a call into MTNL. So, that is what you call is mutual exchange. Now, if you look at this architecture, there is a SIM card, and SIM stands for subscriber identification module, and that is one of the key features of GSM, which we will talk, and it has certain secret authentication information. And then, as I said, BTS houses the radio transceiver, that is the transmitter and the receiver, and it takes care of the radio link and connecting mobile to your BTS, and BSC manages all channel handover allocation and channel setup. When you make a call, and this channel has to be set up, and handover should be taken care of this by this. And MSC I have talked a lot, that is the central component. It does the task of registration of a user and authentication of a user, and at times handover and call routing. That means, when you are making a call from one network to another network, the MSC has to route a call from one system to another system, and at times from one BSC to another BSC. That means, you connect to a BTS, and that BTS to a BSC is probably, if the other receiving BTS is within the same BSC, it may be only routed from the BSC. If it is not in the same BSC, it is in different BSC, then it has to go to MSC. Then MSC is also doing a task of call routing and also connected to fixed network. And each switching center handles dozens of calls. So, that is very important, that the capacity of a switching center is very important, and higher capacity switching center means you have to pay higher cost. Now, this is what I talked about, what each database does. It contains the valid equipment EIR, and the user secret key is in authentication register. Now, GSM comes in multiple flavors. It works on 900 megahertz band, 1800 megahertz band, and 1900 megahertz band, and 900 megaband is called the orange channel in Israel, is most used there, and it digitize the voice at the full coding rate of 20 millisecond per sample. Yes, and that gives you a 206 bits per second bits rate, and which will give you a 13 kilobits per second rate, and that is sampling is important. Now, I will talk what sampling mean now, but here the sampling means when a user makes a call from the home, and our equipments are not simply digital equipments, because we are not using ISDN lines. So, a user makes a call at a 4 kilohertz, and then this is an analog signal, and which goes to a telephone exchange. It may be BTS or whatever, what you call BTS, and then it must be digitized. That means, this analog signal must be converted into digital signal. And keep one thing in mind, I said 4 kilohertz, 4000 hertz. Now, when you digitize it, and the Nyquist theorem very well says that the sampling rate must be double of the maximum frequency or the bandwidth if it is not a narrowband signal. So, I must have 8000 samples per second, because I am using 4 kilohertz signal rate, signaling, or so therefore, 8000 samples per second, and that too if I convert these samples into codes, and since it uses PCM, pulse code modulation, each sample in digitization is represented by 8 bits. And why? Because there are 256 different amplitude possible. So, 8 bits for a sample. When you are sending 8000 samples in 1 second, and one sample is represented by 8 bits, the total bits you are transmitting is 8000 into 8, that is 64,000 bits or 64 kilobits in a second. So, for voice communication, the important point is you need to have at least 64 kilobits per second data rate. A channel must support this, and that is what. And if you look at this, if a user, if you allowing multiple users, that I will talk about. So, 8000 samples per second, and if you divide this 1 by 8000, you will get in 125 microseconds, one sample must be transmitted in 125 microseconds. So, that means to have this, you need a switching service which is capable of transmitting one sample or 8 bits in 125 microseconds. That is the most important part. And so, therefore, the bit rate is important. Now, GSM uses both time division multiplexers and FDMA to let everybody talk. That means, it uses mix of both. Of course, first generation was based on FDMA, but there is no GSM in first generation. It began in second generation, and second generation started with the digital communication, but it that means it uses frequency division multiplexers. That means that means the spectrum is divided into channels based on the frequency. Then each channel is allotted some frequency, and that channel is also using TDMA, time division multiplexers. Now, here the moment I say FDMA, the total 25 megahertz frequency which is used for GSM is divided into 124 different carriers channels. So, total 25 megahertz spectrum, and out of that, if you take first 124, then for first 124 means you divide 25 megahertz by 124, you will get some kilohertz. So, first these kilohertz first channel, then second channel, so and so you have 124 channel frequency, and each base station will get few of those. Then TDMA, each carrier frequency, now out of this 124, each channel of frequency division based on we have 124, out of this 124, each channel will also support 8 bursts. That means, there may be 8 time slots in a channel. So, if you say 124 carriers, each has 8 bursts, that means 124 into 8, that is what the total time division you will have. frame. Now, so time division multiplexers it uses, and each channel is divided into time slots, and each conversion uses one time slot. What does the time slot mean now? Let me focus a little bit here. As I said, one user needs that his one sample must be transmitted in 125 microseconds. If you want to support 100 users at a given point of time, then and each user is transmitting one sample in 125 microseconds. That means I will assume that 125 microseconds be a time slot for the time being. If say one user is allocated one time slot of 125 microseconds, now if you want to support 100 users and each user will like to transmit 125 one sample in 125 microseconds. Now, that means within this 125 microseconds, one sample of each user must be transmitted, right, because one sample needs to be transmitted in 125 microseconds. If you have 100 users to be supported simultaneously, then within that 125 microseconds, one sample of each user must go. That means what now? Now, what you need is this 125 microseconds, within this every user must get a slot. So, that means each user's buffer must be scanned once in 125 microseconds and one sample must be read, and then you can make a combine them and send them, and that is the way what is called time division multiplexers. That means 125 microseconds you are reading data one sample from each user out of the 100. So, that means one user is being time slot of 125 microsecond divided by 100, that means 1.25. Within 1.25 microsecond one user must read one user's data one sample, then next 1.25 microsecond next user's data, then next user's data one sample. So, that means within 125 microsecond you will read 100 samples. So, everybody's sample one sample is being read within 125 microsecond and transmitted. So, therefore, everybody will find that his one sample is being transmitted in 125 microseconds. So, that means what you need is your system switching system should be fast enough to scan, to read and to transmit and to combine these 100 users. So, higher capacity you need, then it will cost and you need faster systems, and that will be very costly. So, that is it says that many conversations are multiplexed into one single channel. That means one sample from each, if you read 100 samples, they are put together. So, in 125 microseconds you are sending 100 samples and multiplexed together, means combined together and then being transmitted, and so on and so on. This is what GSM uses. Now, and user data in GSM is carried on a traffic channel which is defined as a 26 TDMA frames. That means one channel will contain 26 frames of time division multiplexers. So, one frame means in one go, in one scan, if 100 users data is being scanned, 100 samples, that is one frame. So, similarly you have 26 frames in one, you are transmitting in one traffic channel. So, that is how you get high rate, and there are a lot of controls. Now, there are control channels as well. See, one is the data, the call which I am making, that is called data, which will be transmitted, plus at the same time somebody may be also starting a call, dialing a number. So, the call has to be set up, and that when you dial a number, this data has also to be transmitted, and then channel has to be reserved and connection has to be set up. Now, this data, when you dial the number, that is called control data, and this has to go from control channels. So, there are separate control channels which will be used for signaling. That means when a base station is looking for whether a new mobile station has come in its coverage area, has come in its coverage area or not, so that it can find yes, so and so system is in my coverage area, plus whether somebody is dialing and transmitting the number excuse me, this has to be transmitted. So, therefore, if you have, so therefore, you have separate channels for transmitting of control information, because you will like these channels to be free all the time and they may not be continuously being used, whereas the data channels will be used. So, there are separate control channels for signaling, and keep one thing in mind, I have said the mobile to base station, this may be aloha to request network access, that means it is the kind of aloha, that means which no station is waiting for anybody. If I am ready to, and I will send a signal without coordination among the channels, that is what we call it aloha based. Now, so the physical channel in GSM is the time slot, and there may be logical channels which may be control channels as well as data channels. Now, one point which will I make here is that the control signal or the data signal, either both can be carried by the same channels. That means, you have if 10 channels, 9 channels are carrying data and one channel is free. If somebody is making a call, it may call through the same data channel. So, when there is a channel which can be used for both purpose of what you call data transmission as well as control transmission, then we call this in-band signaling. That means, the signal is being carried along with the data band, and the moment the control channels are different than the data channels, and that means certain channels are reserved, that happens in GSM also. Certain channels are reserved, they are only used for carrying control information, they can never be used for carrying data information. So, that means this is called out of band signaling. That means, it cannot, this control information is not carried along with the data, that is called out of band signaling. So, that is where the important point I want to make. Now, SS7 is a signaling system which is used for carrying the control information across the network, and that is a special signaling protocol, and it uses packet switching as we use in the internet. And packet switching means the data is divided into small chunks which we call packets, and each packet is traveling independent of the others and probably carry the information about the address of the receiver as well as the transmitter. Now, GSM also uses SS7 signaling for communication between HLR and VLR. Now, this is very important as far as roaming is concerned. As I said, if somebody who has come from Bangalore to visit Delhi and his mobile is registered in Bangalore because he subscribed the service from Bangalore operator of Airtel. Now, he is in Delhi. So, in Delhi MSC of Airtel will maintain his information in VLR register of Delhi, but his permanent information is contained in the HLR of Bangalore MSC of Airtel. Now, the moment he try to make a call here, then his information goes to this MSC and it must clear that, authenticate that he is a valid user of Airtel, and that will only happen when the information between VLR and HLR is exchanged. That means, the MSC from here must try to verify that there is a user which is registered probably there, and this information has to be verified, and this authentication will be done by the home location MSC, and that will say yes, one is a valid register, a valid user or subscriber in that MSC, and therefore, he will be allowed to go ahead here now, and his visiting information will be stored in VLR of Delhi. So, what you need is, before one is allowed to make a call in a roaming location, that means he is out of his home location, that is what the roaming means. In technical terms, roaming means you are out of your home location, there you are registered with, and therefore, you do not know even after certain distance if your home location changes and you are a visitor. So, it depends on how much coverage an MSC is giving to a particular region, and if you are out of that region, which is where there is a different MSC, then you are roaming around. So, in roaming, the information verification and interchange between HLR, VLR is important, only then the user is authenticated, and this is one of the advanced capabilities which 3G gives. 2G does not provide roaming facility in the beginning, and 3G introduces this. This was the great international achievement as far as GSM 3G was concerned, began with a 2.5 impact, was that provide global or international roaming facility. It does not happen only within the country, it happens internationally as well. Now, so let me talk a few things about the SIM, and this is what we call a subscribers identification or identity module, and this is embedded in a physical SIM card, because SIM card you find has a magnetic material and which contains some information embedded into it, and that is what one of the important point is the number. And initially this was started in 1990, and there is one thing is called IMSI, that is called International Mobile Subscribers Identity, and it is a 14 to 15 digit number, and that is what the first 3 digits which you call MCC, that the mobile country code if I am in Delhi, and then the 3 digit number will identify the country code, and next 2 or 3 digits depending on the country is used for mobile to network code. That means whether I am connected with MTNL or which network. So, mobile to network code is 2 to 3 digit. So, that makes either 2 and then 3 5 digits, and out of 15 digits the remaining 10 digits, if I put that way, is for identification of a subscriber. That is why the number which you are given in a SIM is a 10 digit number, which is your identification number, and the remaining digits which are not shown to you also in the SIM coded are 3 digits for mobile country code and 2 digits for your what you call network code, which may be MTNL or maybe Airtel, and so on and so forth. So, this is a very very important one, and in addition to that, the equipment also, which I did not talk, each handset also have an international number, which I have not given information here. That is a unique number given to each mobile handset, and that too it is also divided on two. One is the handset unique number, other is the code assigned to the manufacturers. So, therefore, sometimes even if you have a SIM loss or something, still the mobile location can be identified your equipment, because equipment number is also registered with the MSC, that is EIR, equipment identification number, is a unique number internationally assigned to each equipment in GSM, and that is stored with the MSC. That is how the valid numbers are. Even sometimes if you look at in some cases, the SIM is immediately destroyed by those who are engaged in wrongdoings. They immediately destroy their SIM, but still they are also identified where they are by the equipment identification number, but that will only happen if the communication begins. Once SIM is destroyed, that equipment is not in use, you cannot. But sometimes they also use the equipment by using different SIM, and that is where the MSC has a equipment identification information. The moment you use a different SIM and start communicating, what you will find is the identification number of the equipment is known, and therefore one is located where one is. So, therefore, the important point is it is not only SIM number, the equipment identification number is one of the key features which is helping in many ways. And this is how I will conclude this series, and if you look at, so what we talked, I will summarize. So, in the throughout 4 or 5 days we have talked on cellular networks, but still there is a scope to talk on what you call IS system 136, which Americans use, and mostly CDMA based systems could be one of the discussion which in future probably, and that the signaling system is very important SS7 which is used in GSM systems, and it has its own ways of handling it. And with this I will conclude, and thank you very much.
Well, friend, I hope you have understood all the things which have been discussing all these in 5 lectures, from fundamentals to up to SI SIM technology and what we call this latest GSM and its aspects. So I hope you have understood well. So I thank all of you for watching the lecture, and on your behalf I thank Dr. D. Lovial for giving such a wonderful lecture and very clearly explaining the things which is difficult to understand reading books. So I hope this will help you. Thank you very much.